Ohio! Welcome Hexchen, Nyanyo Tech, and Ellen. This should be an interesting stream. I currently have set up on my desk my keyboard, that is the target of this project, my Glasgow, the add-on board for Glasgow that allows me to talk to older keyboard protocols, and a very long PS2 cable going between the two. That is the basis of tonight's setup. And as a precursor to stream, I've actually done a little switcheroo. I've turned off the LED code for the moment so that none of the LEDs are running, so I don't blow Glasgow up by asking for too much current. So, I'm just going to give it a little bit longer for a few more people to join. But without too much further ado, I will get started. Including seeing where we got to with PS2 stuff last time around, because, yeah. On a plus side, though, in the meantime, I did get USB enumeration working properly on the keyboard, and if I were to plug in via USB, we would actually see it go through the bulk of enumeration and show up as a USB device, which is cool. I think it's going to be easier if I get the pin out from KeyCAD. KeyCAD nightly. Keyboard. So this is the adapter that we're going through tonight. This port up here specifically. Looks like it's port A, pin 0 and 1 we need. Excellent. Okay, so I plan tonight on getting PS2 support working on the keyboard. That will be both of the... Hey, Any Mouse. 404, welcome. Oh, fair enough. Good luck. Ganbatte, Esden. That's no fun. I hope you're able to work your way out from under the pile soon. So, yeah, good luck, have fun. So, PS2 is the second of the two protocols that this needs to work with and talk. So, I figure we've got USB working now, or at least working enough. Time to get PS2 going. And... do we have any PS2 headers open? No, it doesn't look like. And also get key scanning going, because those are the two things we haven't actually yet done on the board. So, this should be interesting. Let's put F interrupt vectors. B. Maybe E. Okay, so we do have a PS2 interrupt. That is all plumbed in. Let me show you the setup with Glasgow. When this can see the right console, that would help. There we go. So, as you can see, I've got my Glasgow attached here, and we can turn on the port that the keyboard is attached to. That allows us to then do reprogramming So just to prove that the keyboard is actually plugged in and doing stuff, even if it's not really doing very much yet. So we want to do a... Where is the PS2 stuff? PS2 host. Oh, that's interesting. Rev C0 Plus is required. Ooh. Well, it's a good thing I've got a Rev C2 here. So we want 5V IO. Jeez, I can't type apparently. Port is only A. I didn't check which way around the clock in the data flow. Whoops. 1 second, I need to grab a piece of data again from schematics. Clock on pin 0. Hey, we're using the defaults. Excellent. So, send each byte from init as an initialization command. I actually don't know how that one works. Oh, my installation of Yosis needs a rebuild. That's something I didn't check before I started stream. Whoopsie. Let's see if we can fix that. Let's see, is it in packages or is it on my other half's machine at the moment? Because if I do which Yosis, user bin Yosis, and we do pacman QL user bin Yosis. Oh, not QL, QF, sorry. No, sorry, owns, not file, owns. I'm thinking of RPM. Yeah, false FPGA tools git is on her machine. Give me a second, I have to go and find something. I hope I can find it. There it is. Okay. Boss. FPGA tools git. This is not the thing I was expecting to have to fix before I could do anything. So it needs... true. You make a good point. This has got a few things to build, as you can tell. while that's doing its thing, let us have a look and see what we've got here with regards to PS2 and how close we were or weren't to having PS2 do useful things for us. I need a window from another workspace. Workspace. 1 second. I think it's this one. Yes, excellent. That seems broken. Ah, there we go. That's better. That's more readable. So, the yellow background thing was already pretty awful, so... Hey, Aaron! And welcome, Fred, by the way. Ah, good, good, good. Keyboard to host is with 11 bits. Host to keyboard. How does the initialization command sequence look? Well, that really doesn't actually help me. Ah, host commands. Byte of FF, there we go. I'm gonna guess that is what a host would typically send on booting a PC. Oh, and that's also got a scan code set. There we go. Okay. Handy, handy. So, we currently set up Porty to do what we're calling wired AND with pull-ups. Ooh, I should set up debug UART so I can actually print out what's happening as it tries to start. Oh, she's making sure I don't forget to do mine. So what we probably want to do is... You are right. Debug UART. Freya, the puns. We want to write that initializing PS2 And then reading from PS2 port. Red. And then we can then do UART write hex debug UART data, I think is the one. Yeah, that's the data that the UART has read. Because we're treating PS2 like it can be dealt with via UART only. Which is going to be interesting, but, you know. Now, the mode we put the UART into is 8-bit with parity. And what is that again? How's everyone doing, by the way? I did mean to ask that earlier and I clean forgot. Control C. Stop bit count. Okay. So this is one stopped bit. So that's 8, 9, 10. I wonder if there's a stop bit by default. There should be. It doesn't say though in here, which is a little problematic. Meow. Darn it, making me meow again. God, there are so many cat girls in chat, it's great. Okay, so it looks like we can probably do a USART E0 data equals data, having checked that we... yeah, the intersection of cat girls and technology. I approve of that description. We probably want to make sure while not USART E0.status bit 40. Just to make sure that the transmission goes out. Sending or writing to PS2 port. Ooh, that's not good, actually. Apparently someone broke protobuf support at some point. I'll fix that once I've got this written. Oh, so we have to go and fix I've just disabled proto buff for right now. That was SHA-256. That's good. Well, that's going to take a while again. It's rebuilding a large chunk of Yosis. Welcome, Amy. I'm gonna... We'll actually make that do stuff in a bit, but I want to silence a warning so I can actually see what's wrong. Ah, I was a bad girl in here at some point. There's an unsigned. There's... another unsigned here because of... I mean with my signed unsignedness of certain operations I'm doing. I forgot a few U's off some things here and it causes warnings. Correctly so. What can I say? I'm very good at being bad. Okay, that's looking better. It's doing ABC now. I need this to work in order to be able to use Glasgow, which is why this is currently the bottleneck. Sorry. This is where I'm very, very glad that my PC is water-cooled, which is why you're not hearing tons of fan noise right now. It's okay, Hex-chan. Sorry, Nyan. You can be Nyan binary too. That's Yosis. This is currently doing Trellis. Yes, Aaron, you can be a Nyan bot. while that's building, let's kick Minicom, I think it was. Minicom, sorry, off. So I've just rerun the program on the device, and we didn't see anything from the startup sequence here. Appears to init appeared not to run. Oh, which bit is doing the UART initialization? I'm betting that was probably an LED in it, which is currently offline because otherwise I'll draw too much power. Which is not defined in the scope. That's frustrating. Yep. Bingo! Oh, interesting. What is triggering that? So this is on port E int 0's vector, which puts it onto the port system. Int 0 mask. These bits are used to mask which pins can be used to sources for port interrupt 0. So this is picking the receive line. I think? No. That's picking the clock line. Why did I do that? I regret not writing more documentation as to why I did this. Ah, because the host will pull the clock low before data is driven. So this was chosen because the clock is the one that's going to go low. Even though it's an output. What's the interrupt control stuff set to at the moment? So we're only enabling even interrupt 0 level medium. So this needs to reset port E int flags. So this needs to go back to 0 to stop the interrupt from firing continually. Which it's still firing continually. How is the interrupt being generated? Why is it being generated? That's the next question. Take care, Freya. Thanks for watching. I know you've had a bit of a rough day. This is the event system. No, it doesn't feel like we're in the right part of the datasheet at all. There's synchronous and asynchronous sensing. Kind of a shame I can't get any scope probes in there anymore to be able to see what the PS2 signals are doing. This has me a little perplexed, honestly. So, port pin 2 is for full async. That is the RX pin on this port. Hi, Obliterus. Welcome, welcome. I'm trying to figure out why this interrupt keeps just firing continually when it shouldn't. Like, yikes levels of firing continually. Or better than that apparently. 4 E flags here should be stopping the interrupt from going crazy, but it's not. And I'm trying to work out how I can determine what edge the pin interrupt is actually occurring on. I know there's a mux involved. In theory, we should be using synchronous sense. Because the processor is working so much faster than PS2 can. That's it going into a buffer. The input sense configuration is set by these registers. Okay. So we don't care about slew rate limiting. We are not using inverted inputs. The key pins are in wide and pull, which is where we have wide and but with a pull up. I almost want to say this should be falling edge. I don't know how I make sure that this is synchronous. That will be the other thing to figure out, is how to make sure that that's synchronous. It does talk about it, but it doesn't talk about how it's set up. Falling edge, always triggered. Hi, welcome Steffi. No worries. I'm just trying to figure out how... I've remembered how I changed the interrupt sensing mode. Oh. But I've forgotten how we change to synchronous sensing here, so that we get the correct input chain. The other thing I've currently got running while all of this is happening is a rebuild of the tools, because my build's broken. Oops. That didn't change anything. Interesting. Like, why does my Glasgow not work? Oh, because the tools are broken. Yeah, that's a mood. I've temporarily turned the keyboard back off because that was just spewing. We really need this so I can then run PS2 host applet. Let's try and see if we can find how the synchronous mode stuff works. Peripheral clocks output on a port pin. Interesting. Pretty sure we don't want to do that, but that would be very interesting. Oh, that is cursed. That is very cursed. Interesting. There's a whole part of pin remapping which we don't really care about. slew rate limiting, input inversion, mode of operation of the pin, only port A through F support the buffer disable option. Huh. Yeah, you've had some rough times with the bad RAM, huh? Swap an event out register. What even is this? Oh, interesting. We can actually get this to output the clock on a pin for the FPO. Interesting. Then there's a virtual port. And then there's the register summary. That's frustrating. So it doesn't look like you can actually control whether or not that synchronizer is in use or not. It just either is or isn't. But they haven't bothered to document on what pins it is. Well, that's fun. I'm inclined to get the key matrix scanning stuff working at the very least. For right now, I will disable... Ooh, here's 2 in it. I've got the key in it call in there already, so let us see if we can implement scanning on a row first. So the column bits are on A, row signals are on F. So if we set this for column 1, which is the column A is on, we've got UART init here, so we can use the debug UART. Right there. UART right. Debug UART. Initializing key scanning. Now this is going to need some help from a timer at some point to get the keyboards to periodically do the scanning. But the first thing I want to do is check. Now what row is which? That's the next question I've got in my head. I want to check and see if I hold down A while programming and it runs the firmware, do we see the key being pressed? Can it see that? That is row 4. that that's on. Zero to 4. Let's just check. PF3. Okay. Ah, hey, the tools have finished building at last. Just got to copy a file back for Aki because otherwise she won't get the benefit from this. This is -8 actually. I should have done an update to the... Oopsie. I should have updated the PKG rel, and I didn't. And I did a cleanup. Well, that was stupid of me. Oh well. Yeah, that'll do. There. Okay, so if I program the keyboard, so I'm going to make that smaller, because that's just annoying, the size it normally goes to when you're that big. I forgot an FSV there. Haha, it didn't build. Interesting that we get nothing out here. Or did we? Hey, there we go. So we get a key scan on A that way. Is that in the right spot? C0. Why C? I only pressed down one key. Interesting. Well, we can turn the PS2 stuff back on and see what happens if we ask Glasgow to do an initialization sequence, I guess, because now that Glasgow should work, that's useful to do. Take care, Steffi. Thanks for dropping in. Thank you, so do I. Now that we've got tools, maybe we can. Helps if I go to the right thing. Right, that one, there we go. So, Glasgow should now go and build a thing. Which it appears to be. Interesting. That triggers a read from the PS2 port, but something isn't right there. But at least it stopped going cuckoo. So there is that. See, it's no longer going cuckoo, but I don't see it actually reading from the PS2 port correctly. If I restart the keyboard, I just unplugged and plugged in the extension board. And I rerun Glasgow. I hate that I can't, There we go. So this is what happens when Glasgow runs now. I wish. Curious and broken. Well, the only thing I can think to do right now then, without going and digging more equipment out, because I want to get something done at least, is I'm going to get key scanning going. So we'll need this. But before I do that, I'm going to as well need... Okay. End of that song's kind of nuts. I'm gonna need a timer. Let's go with a TC0. Timer type 0, that is. 16-bit should be more than enough. Famous last words. True. I'm just trying to think on how do I want to set this up exactly, because I need the interrupts, not the output side of things. So we can just nick a timer, probably one from port A. Is the port A1 called? Looks like TCA0. DMA TCC0 E0 D0 F0 Oh, it looks like TCC0 is the first one we get to use. Oh well. Suits me fine though. So we want to how's this gonna work? We want to do a scan once every 1,000th of a second, i.e. 1 kilohertz. So 1 kilohertz versus the 2 megahertz f per. Other way around. That's a value of 2000 for the counter. So we can use top equals 2000. Make sure that TCC0 count is 0. Oh, CNT 0. Make sure that TCC0 bottom is also 0. Oh, intriguing. We'll also want to set the prescaler to basically off, which is TCC0. Control A is flux selection 1. We don't want the capture enable stuff on. That's F0. Per is the top value. Or is it? We want to make sure that we're in a normal mode counter, because otherwise things will break. The headers are missing a lot of information, aren't they? Like, they do actually work. Welcome, by the way, Jiggly Girls. Vertical mice relieve the... Basically, it's to do with pronation. When we are typing or using a mouse normally, we pronate our hands. This isn't a natural position for our hands to be in, which is part of why it induces RSI. Vertical mice allow your hand to, if your wrists are really, really bad, a vertical mouse which has got a trackball on it, allows you to hold your hand in a non-pronated position, which is the same position you'd like shake someone's hand in, which is far better for already messed up wrists and so on. So it's better for RSI. I hope that makes some sense. I hate this. The header defines individual selection bit masks, but it doesn't... It doesn't define enums. So what we really want is to be able to do that, and likewise it'll be clock cell CLK GC, which means we need to define some more constants. This is something I'm not very much enjoying having to do lots of, but whatever. So bytecode normal is defined as all zeros. For compatibility with future devices, always write these bits to 0 when this register is written. Okay. It says to explicitly write them to 0. Where's the clock bit stuff gone again? I went straight past it. Yep. So this sets to 0, 1. Again, those bits to be written to 0, so we are doing the right thing there. That's nice. What I want to do is I want to do a compare. I want to compare the timer value against a set point. Which I think means I have to set top No, oh, I see. Bottom and top are implicit. They are 0 and 65535. I was about to say 6. No, it's not 6. Fair enough. I don't want to be generating signals though. A lot of this stuff is geared to, hey, you want to output a signal, right? No, I don't actually. I just want to do compare. In normal mode, when we reach top, counter will be reset to 0. Normal mode. That would be... this mode, where top is set as per. Okay, that works for me, actually. Waveform generation modes. So we want to do a CCA enable. Along with WG mode normal. Which again we're going to have to find a value for because the darn thing doesn't do it itself. Which is apparently 0, nicely enough. Capture double buffering. No, we don't care about that. So we get an event in this instance, which allows us to say that it overflowed. Ah, right. We can use the fact that there are timer counter 0 overflow vector. Haha. So if I put in here, this is the key IRQ. Now I have to go and define that. And that needs me to pull another header in. Hang on. When did I... Ah. That would be problematic. I'm already initializing a timer for... Oh, I see. Okay. So yeah, apparently I'm already using that one. Can't use that again. So what other timers do we have available? We could use port E's. Or port D's. I want to go with port D, I think. Apparently, if I take out the zeros in these, it should find the... Yeah, okay. So apparently I already have some, enums defined, I just had forgotten what on earth they were. So, apparently I do not need to set the capture compare stuff on. I can just use byte mode normal, configure the interrupt up, overflow, interrupt level. Let's go with high, because it's a high priority that we deal with rescanning the key matrix state. I'll check what that actually does before I commit that, of course. Knowing me, though, that probably resets interrupt state. Oh no, it clears all of this stuff to do with direction and various other things. And I'm guessing I've missed an ampersand? Oh no, I'm clearing all those bits. Then we want to then say we want to do an update. Forced update. We set what we want to update things to. That's actually timer initialization done. Okay. So we should now be getting these interrupts every so often. Which, if I look at the LED code again, they don't need any special handling to reset the overflow condition. We just have to fire the interrupt handler, it looks. Yeah, I'm not doing anything special in here to deal with this interrupt state, so Let us see then. For unit T, I is less than, well, it's actually set to 0 explicitly. I is less than the 21 columns that we have. Port A out is I, because that's what we are scanning. Then we want to put in a couple of cycles for this to all settle down. AVR built-ins. Not wanted to open, not control key. Built-ins. There is a built-in for just sleeping a cycle, nopping basically. Or there should be a built-in for nopping. Oh, thanks for the follow. Wow, I cannot read that on that screen. Thanks for the follow, Max Imagui? Gui, sorry. And welcome to the stream. I just butchered your username, I know, I'm very sorry. So apparently there isn't a built-in for what I want to do, which is emit a knock or two. I wonder if it is defined though. Oh, CXC, AVR include. So there's an allocer built in, which I do not want to touch. There's those. Absolute value. And delay cycles. Oh, okay. There is a CPU function header that we can use. Which gives us this underscore nop macro. Sure, that'll work. So what we're doing here is we're doing a write onto the port that represents our column that we want to scan. And then after a couple of cycles, we then want to do a read back of that port pin to see what the keys themselves are actually doing, right? And this will happen once every 1,000th of a second, and we should see a nice, here's all the key states in this current iteration. So if I program that on the board, that is way too fast to read. Okay. Poor UART wasn't able to keep up even. I'm gonna keep an iterations count, and we're gonna do that printout once every second. Which is 1,000 iterations, which means we need a 16-bit counter. But it's good to see that that interrupt just worked. So you can do plus that, then modulo 1000. Well, actually, if scan iterations is greater than or equal to 1000, set to 0. And then if not scan iterations, i.e. if it's 0, do that. That's much better, although we aren't... Oh no, there we go. Interesting, we're able to see key scans happen, but then they're not clearing back down. That's a curious one. So that was me pressing keys on the left-handmost column that was enabling those IOs, and then me pressing keys further down the keyboard, clearing them again. So I'll just demonstrate that with like the control key there, and then if I hit space, it clears. And if I hit control again, and then space, escape, and apparently something else, F1, yeah, so escape F1, which obviously this isn't the behavior we want, but it's interesting all the same. I'm wondering why it's latching. So in theory, port A should all be output pins. I'm gonna disable this logic about totem polling them. Yeah, it hasn't changed anything. Yeah, it doesn't matter what keys I'm hitting, it's always behaving the exact same way. Interesting. So those aren't a problem. They're not harming anything, so we'll leave those in. I/O ports. So direction is set to our column mask. It's almost like the scanning isn't happening. I'm gonna get a multimeter out and see if... I'm gonna disable the timer code again real quick. And I'm going to re-enable that bit of code that sets the port that we are asking data from to something other than 0, port 0. And I'm going to use a multimeter and see what I can read out on that column. I'm sorry you can't see what I'm doing, but I didn't think to set a camera up today. Which probably would have been a bit more interesting, right? I might still go and grab the camera, don't worry. So, if I take that ground pad there, 3 volts there, which shouldn't be. Some number of millivolts. Interesting. If I hold that key in, I see 3 volts there, as expected. Okay. So what happens if I write that to 2? Let's try that next. Zero volts there. There. And 3 volts there still. Interesting. Why is that latching then? Port F is behaving in a very odd way here. But also port A isn't doing what it's supposed to do. Let's see, 8 would be the next decoder along. Luckily the decoders are on the back of the board, so I can get to them. Otherwise we really would have problems right now, because I'd be having to take the entire front of the board off, which, not happening. 3 volts there, which shouldn't be. 1, 2, 3, 4, 5, 6, 7, 8. And nothing on that one. Interesting. I am probably going to get the camera out in a moment, because this is going to be a more interesting stream if you can actually see what I'm doing. One moment, please. Yeah, that's a thing. plugging things in. This won't take me very long. On would be. Alright, no memory card. Where is the memory card for my camera right now? Oh, it is in this laptop, okay. Heh. Whoops. I'm not going to show you it while it's complaining that it can't find the memory card. So this is what I'm currently looking at, and there's your PS2 link, like I was saying earlier. And if we look down this end of the board over here, there's a decoder right here, right? In theory, right now, with the way I configured the keyboard and I programmed it, if I put a multimeter in shot, hopefully that is readable. I've got my headphones trapped. There we go. And if we look between a ground pad here and a diode, we see 3.3 volts here. This is column 0, as far as the firmware is concerned. And the next column along here, if I test that, we see the big bump kiss, the big 0, which is not good, but if we then go further along, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, because of the way that this is laid out. We see, again, if we look at the diode next to it, nada, nothing. And we can do that with all the diodes the whole way along, and we're not seeing any positive indication of it actually being able to scan, which explains the behavior we were seeing somewhat. The thing that it doesn't explain is why the CPU was latching the last seen state. The reason I'm curious about that, and I'm going to have to poke the I/O system quite hard for it, is if I go from a ground pad to the other side of a key and I press that key in, we're able to see yeah, there's our 3 volts. Other side of the key, we're able to see me pressing the key. So we know that physically it's not latching, which means it's an entirely a microcontroller thing. Ah, screw it, I'll let this one play. This is a nice song. So even though we've asked it to turn on what should be the 8th one along, 9th one along. Oh, okay. Not your cup of tea, huh, HexGen? So even though we were asking for quite such far along, which should have put us onto the next decoder down from this one here, it clearly wasn't, so we need to do a couple of things. Well, I'm going to unpower the board for a second. I want to do some testing of some continuity. So I've just told Glasgow to turn that port off. So let's put us in continuity mode. Now, in theory, there we go. In theory, there should be no continuity between these two diode packs, for example, because they should be being fed from two different lines of the decoder here. So if I do that, no continuity, which is good. Whereas if I do that, continuity. So that's a good sign that we don't have a short underneath this chip. There. The next one I need to do, and this is where things get a bit interesting, is we need to check pairs of pins here. So there's no short there. That's because wow, that's annoying. So I'm just testing every pair of pins going along. That seems like it's okay. Let's just test this end one. Yeah, that seems fine. And this end one? Yeah. I'm happy that there are no shorts on the upper half of that chip, which is the part which is coming from the microcontroller. Which actually means that there aren't any shorts the whole way down the board. Because the data lines coming out here are the same ones coming down to... it's a little off camera still. Oops. Coming down to here, for example. That's the same set of data lines there as over here. So testing continuity on them tests continuity across the whole thing. I want to get KeyCAD up real quick. And check what voltages should be applied to what pins here. Okay. So if we go back into voltage mode, Oops. So I've just programmed the board to hopefully only have this column here on, which should mean the microcontroller is outputting a 1 on that port, which should mean if I go and check now, pin over here is column 1. Oh, now that's interesting. Hey, Nikki. Welcome, welcome. I am going cuckoo as my keyboard is just going a little haywire. That pin is at 0 like I'd expect. 0. 0. I'm gonna check the power feed. Power feed is nice and stable. So that makes that behavior even more intriguing. That's decol 1. Let's put a 2 on the bus, which should make it so this pin goes to low, and it is, and the next pin along should be the one high, which it kind of is. I didn't do something silly like solder that on upside down, did I? That would be embarrassing. So that looks like the pin 1 marker is over here. Yeah, that looks like a pin 1 marker to me. Which is actually correct, because I've put pin 1 as being over here, which is where decol 1 comes down to. So unless I've got the pin out of this thing wrong, I don't have a magnifying glass. I know. I'm terrible. But that's a pin 1 marker. That dot right there is a pin 1 marker. And this is pin 1 over here according to the board. Which should be pin A0 of the decoder. I'm gonna get the datasheet for this thing up. So pin 0, sorry, pin 1 is A0. It's all good. So it looks like these are active high. Yeah, active high mutually exclusive outputs, which is what this board is designed for. Yeah, this all matches what we were seeing, actually. It's kind of annoying that the chip that we're actually after is this one on the side that the camera display is on. But, if I look at this pin here, that is currently low, and that would be A0. A1 is the one going a little bonkers. And A2 is that ground. So if we look again at these, we're seeing 3.3 volts there. That's coming from Y0. Then 0 volts there from Y1, even though that should be the one that's on right now. Sorry, you can't see that. Let me zoom you back out. So I've just checked this one here. If I test this, it's showing 3.3 volts. This isn't the output from what is Y0 in the datasheet. This one here is at 0 volts. That's the output from Y1. This one's also at 0 volts. This is the output from Y2. But this one here should be at 3.3 volts. By all means and rights, based on the available data we have. Which is a touch frustrating, honestly. Because I thought we had this solved. What I'm particularly intrigued about, though, is that A1 here, if I do that, come on. There we go. We can see that that pin is going kind of cuckoo right now. Indeed it does. Hey, it's better than being hydrofluoric acid, okay? The acid where you only know when it's stopped being a problem when you stop screaming. My definition of fine definitely does not include my bones being a molten mess. So, this raises some very intriguing questions as to why that pin is going cuckoo. And I think most of our answers are going to be in the port setup. Oh, jeez, HexGen. You are quite the romantic, aren't you? This is a little unwieldy to actually try and put the keyboard somewhere useful. That's a bit better. Multi-messers are fine. So, what I want to first check here is what the column mask is doing. It should be octal 37. 37, hex 1F. So let's find out. Ah, right, the, I haven't got the debug UART stuff plugged in right now. Crud. As in hexadecimal. Sorry, HexGen. That's fair. Nothing to be sorry about. Hey, you're fine. No bully yourself. That's my debug UART there. And okay, our column mask is what it should be. So that is the right way round. So port A gets cleared. We don't have slew rate limiting enabled. The outputs are not inverted. And we've asked it to go totem pole. That's interesting. It shouldn't be doing what it's doing. I might have to get the scope out and put the scope on this and find out what it's doing that way. We aren't using the pull-ups. Or we shouldn't be, at least. Where are the... Here they are. So, totem pole here is what we're after. Port F. Who knows? I hope not, because we are so far into the build of this particular board that well, I can't even get to the processor right now. There's a steel plate in the way. 1.6mm thick steel plate stopping me from messing with the processor means I have to take all of the keys off. You don't want me to have to take all the keys off. Now, we specifically do not want bus keeper, so I'm actually going to go through and port F, pin 0 control, port O, PC, totem, and so on, so that we guarantee that all 6 bits are behaving the way we expect them to behave, I think. Oh, yeah, it could be. I again hope not, though. Yeah, still doing that, keeping the previous state thing. And then not registering key presses. Like, if I press these keys, it ain't doing anything. But if I press the ones down the far end... there it's doing the thing that we don't want it to do. What's curious is why is port F keeping value when it shouldn't? PD Max. What is that? Oh shit. What's the bets that I've forgotten to make sure that these are digital pins? How am I doing that for other peripherals? I'm not? That seems weird. Input disable. No, we don't want input disable. Yeah, that's for analog digital conversion, that kind of thing. In the input data value, it's okay, Anymouse. We've been having a frustrating time with PS2 and key scanning both. They don't want to behave properly, and I think I'm about to go and bust out my scope. I'm currently trying to figure out why on port F the pins are acting like they're in bus keeper mode. Which they shouldn't be. What are the alternative functions currently set to? No, that wasn't... Where? I've forgotten how some of this stuff works because I haven't dealt with AVR in a little too many streams. In theory, it should only be doing anything with alternative functions if we are specifically enabling those. I think. Digital to analog, analog to digital, external bus. None of these are items that we're using. I/O ports, interrupts. The event subsystem, which we are also not using. This is how the actual CPU works. Port F does have things like an SPI bus and a USART, but we're not using those. We've got those quite strictly controlled, and port A has all the analog stuff on it, but we're not using that. I feel I'm gonna get the scope out. I'm gonna see what that signal is doing in the hardware. This is gonna be fun. Hang on. Pick up all the bits. There we go. Why is my headphone cable stuck? Come on, there we go. Why is my headphone cable? That seems to be the question of the night, huh? In the port, please. There we go. Oh, I should also show the really, really cool thing that Aki did. Let me grab you real quick, and then you can watch my scope boot as I go and dunk Glasgow in stuff. Yeah, that was good of me. Still, you get to watch my scope boot, so just a second. Aki did a really cool thing. Yeah. I don't know anybody else has this firmware, by the way. Yeah, it's good. And I accidentally did the thing, so I've got to go and grab some paper towels. She is unfortunately unable to be with us right now, as she is asleep. She was up for like 26 hours. Right, I will be right back. I need to grab kitchen towel. Oh, fun. Or rather, not so fun. Welcome back. I have successfully managed to dunk half my hardware dev boards in Coca-Cola and rum. So I'm currently cleaning my desk. Actually, it's not strictly speaking Coca-Cola, but yeah, whoops. No, it hasn't got ice. Well, I guess you could say no, it has, because I've got a Glasgow which has got a nice 40 on it, so yeah. Soda. Cola, strictly speaking. Come now, obliterous. Oof. That's a lot of property damage. Okay, that's looking more manageable by the moment. Just cleaning the spills. Or oh, that looks good. Boards all came back on just fine, so we can continue. Ah, right, I have to do the thing with Glasgow to make it stop being dumb with the PS2 port. Okay. My probe for channel 1. Yeah. Isn't that criminal negligence or something like that? Because it should never be allowed to get that bad. Oof. Yeah. You have it rough, don't you, Obliterus? Right. Sorry about that. Okay. I'm gonna disconnect the debug UART stuff because right now I need to be able to turn the board over. Smack my lamp. Go me. And we need to... how to do the grounding? Because that ain't gonna fit. I'm going to need my soldering iron out, and I'm going to need to tack a wire onto one of these pads so that we can ground things. This is about as thick as I've got, which is thin. That is some... there you go. Yeah, not particularly big. So, time to get the scope, my soldering iron out, which means I need to put a cable back on the back of my scope. Also, the nice thing about this stuff is it's enameled wire that you can de-insulate using a soldering iron. I wasn't expecting this to go into being a hardware fixaroo stream. 1 second while I get my iron set up. Okay. Also, I should unpower the board again. Otherwise, this is gonna suck. Because I would be putting power through Glasgow, which ain't good for it. Hmm. I hope that that is a good enough connection. That's going to be a problem actually. That's not a good connection. This stuff can be a bit of a pain to work with sometimes. There we go. Now I can feel heat going up the wire. That's some good insulation. That's much better. Now we have somewhere to clip a ground onto. Like that, there we go. That makes me happy. Right, time to switch things back so I can then run my scope again. I need more PowerPoints. And I don't mean the program. Oof. That sounds like someone's about to get fired. That sounds like they knew it was bad. Okay. After that little kerfuffle. Oh, I've got to power the board again. That would help. So let's do a check. This pin here should be and is at a low state. I got a good connection. Yeah. Whereas this pin why is that low? Pardon me. Okay, that reads as 3 volts. Where has the decoders gone again? I have a decoder enabled that I don't want enabled right now. Trigger is currently edge source channel 1. Measurements. And the measurements. Mode should change, yeah, that's the trigger mode. Interesting. got measurements off at the moment. Cursors are off. Acquisition normal. I'm not using the I/O stuff right now. Pass, fail, record, system. Ah, there it is. It's in the maths menu, of course it is, because that's so obvious, right? Yeah, probe is in 10x mode. So if I put out as 1 again, that pin is still low. Huh. So in theory, that right there should be a connection for a pin, and that is currently low. There's another one over here, which is reportedly also low, even though those shouldn't be. That's high. Oh, hang on, interesting. Port A, that was low, low. Low. That pin there is high. So this pin here is high. That one's low. Have I managed to hook these up backwards or something? That same pin is still high, even though I've changed port A to output 2, in theory. That's really weird. I'm just going to go along all these diodes and test what voltage they're at, and if they're oscillating. Which they are all low and not oscillating. That's really intriguing. So it's this pin right here that is reading as high, even though it should be the one over here And here. Which, those are looking awful, those joints. But that's not the reason why it's broken. That's funny. If it wasn't tragic. That is the low voltage I would expect it to be. I see the key doing its thing properly. Oh yeah. It's like many accidents, they're not really accidental, they happen because reasons. Figuring out what those reasons are and who to appropriately kick as a result is, well, fun. Is that actually writable? Let's actually check something here. And that is that, this output port is actually writable. Because that could be part of the problem here. This register sets the data output value for the individual pins of the port. Yeah, so that's exactly as I would expect it to be. Yes, deferred maintenance is always expensive, particularly to other humans' lives. And yes, I did just throw a whole pile of people under a bus there. So the direction register, we're setting... If DIRN is written to 1, pin N is configured as an input, as an output pin. So this should be setting all of those pins as outputs. That should be pulling all of the port F pins to be inputs. Which I'm gonna do a row mask thing real quick. Yeah, that's definitely all port F. I like how you call that sheer dumb luck, like it should be called. Oh! I put that bit of code back in, which is bad right now, because that's why I wasn't able to see the pin doing what I was expecting it to do, probably. So, if I now I really need a way to be able to show what my scope is showing. Where has it gone? Electronics? Yeah, DS remote. Oh, hang on. DS remote is broken, isn't it? Yeah, cannot write to device. I hate that. My remote control software doesn't work since I upgraded my scope. Great. So, you'll just have to go with me telling you what I'm seeing on the screen of my scope. So, on this pin, we get a fat low, fat nothing. On this pin, we're also getting nothing. And again, it's not until we're all the way down here. Yeah, if I just run the probe down along, it's not until I get to the end down here that we see a high pin. I'm always able to get that one pin is high. And I can't get at those, interestingly. Okay. This is frustrating. Because I don't know why. I don't know why this chip is misbehaving. And I don't have one to just breadboard. And it's not working according to its own datasheet. That's the biggest annoyance. Is like, if we look at the datasheet for this chip, unless the processor is just doing utterly the wrong thing. Because it should be that if this pin goes high, sorry, if all of these pins are low, oh, it'd be E3 here that needs to be high. That's pin 6, which, 0, and then along the top, what's the pin out? Six is that one right there. Ah, that's the one that's high. Everything else is low. Interesting. That's very intriguing. Well, that doesn't explain why writing port A out isn't writing port A. I'm getting annoyed at this, actually, at this point, because clearly this isn't working the way it is supposed to work. Like, if I disable all of the shenanigans with setting up port A pins here, and we reflash that onto the chip, and I look at port pin, it's this pin here, this should now be high, and I'm not seeing a high there. What's if I don't accidentally mess with the wrong control? I was meant to do that one. I wanted to increase my time base sample over a longer period of time. Oh yeah, and it's just staying low. Which makes it even weirder that my multimeter was saying it was going high. If I check that same pin I've just been checking with my multimeter again, it's in voltage mode. This is like not the content I wanted for tonight. I was hoping to do something a little less boring. Sorry everyone. But I didn't know that the hardware still had problems like this. So if we look at this pin, we're seeing my meter going absolutely berserk and all over the place on it. While, if I check the pin next door, that's a very solid 0 volts. It's grounded through the processor. It shouldn't be, but maybe. Yeah. I found a very annoying bug though, because it's a bug that doesn't make sense. So, this is the same chip, just so you can see, yep, this is the same chip. Decol 1 here, through 5 here, that's why it was high. These should be the column pins coming in from microcontroller all the way over here. Which unfortunately I can't get at because of the key plate. So I just have to hope there isn't like an internal break in the board. But we're seeing, even when we write what should be 0, 1, 0, 0, 0, and then someone connected pads, we're not seeing that on the microcontroller pins, it would seem. Because these pins aren't behaving the way that they should behave. If that makes some sense. So there's the decode happening there. And if we go and look at processor, there's the row pins coming back in, and there's the decol pins. 1, 0, 1, 2, 3, and 4 going to hole 1, 2, 3, 4, and 5. I can't get to these pins on the microcontroller because there's a steel plate in the way. gonna try something here. I'll put the totem pole stuff back in, because that shouldn't really make a difference. And if I put that on the board... it's not quite 0 volts, it's not as low as the other pins, but it's not 3.3 volts, which explains why it's not turning the signal on properly. It's at... what even is that? That's 0.3 volts? Oh, that's interesting though. I can see that it's trying to pull that pin high. If I change this to out equals 1... interesting. Oh, double interesting. I see it go high for a second. On programming. Oh, that's interesting. No, it's almost like the microcontroller's unable to drive the pin properly. If I look at this pin, sorry, there we go, you can now see that I'm looking at that pin, and I write a 1 on booting the micro, I see it bounce up and then it slowly falls back down. This is almost like the direction stuff is a lie. But I actually think this might just be that something else... I hope not. It's an expensive problem to get, Amy. I'm trying to make this so you can see what I'm doing a little nicer. Right, so... doing this, like I just did, meant that these pins are now currently all reading as 0 volts. So if I plonk the probe on... come on. There. That's reading solidly as 0 volts right now. If I change it back, I see the pin goes driven, and if I change it to out equals 2 again, I see it go high for a second and then pull back down. There's an RC constant going on, meaning it's not actually being continually driven, which is a bit weird, because this microcontroller should be continually driving that pin. I'm gonna see if there's anything else on port A that could be messing with this. That's a no. Key matrix is the only thing to mess with port A. I'm going to re-enable this interrupt, because what I'm going to do next is I'm going to see if I can wiggle the toe beans of this pin. I'm going to aim very, very specifically at that one pin. And I'm going to continually do the out clear thing to force it to be, sorry, not out clear, DIR thing, to force the direction to be output. And I'm seeing that low but non-zero voltage again. Let's do an out toggle. And I can see that toggling. Hey, welcome back, Aaron. Yeah, I'm still doing the thing because I'm getting annoying problems to do with key scanning logic that just won't work. I'm getting a very low level signal when I should be getting a nice strong drive here. Yeah, that's just not doing what it's supposed to do. I can see it wiggling its toe bean, but it's doing so going between 0 and 0.3 volts when it should be going between 0 and 3.3 volts. So of course this chip is just like, I don't know. It is pulling all the way to ground, but it's not pulling high like it should. So what happens if we do port SR len bit mask? This should slew rate these pins. So if this is an overcurrent condition, that will stop the overcurrent condition in its tracks. And now I'm not seeing the pin toggle. What am I? Doop-a-doop-a-doop. There we go. I toggled the wrong knob on the dial. Good question. Even sweeping time bases, I'm not really seeing that pin toggle now. So I'm going to get rid of this. Because clearly that's not working for us. And I'm going to make it so that this pin has inverted I/O. Which is the one that we are wiggling. And I'm able to see that wiggling again, but again it's going between 0 and 3.3 volt, and 0.3 volts, rather than 3.3 volts. The problem I've got is I can't actually get a probe down far enough to probe another one of these, unless I just don't connect a ground on the probe, which... That's fair. That's, it's doing something, but it's so noisy from all the AC it's picking up that I can't actually tell what. Interesting. There's one more down here. And it's the same story here. So that should set all of the pin bits to 0. That should set them as outputs. I'm going to get rid of the inverted logic, because we don't really want that. And I'm going to put the previous scan stuff back in case I can get a probe onto another pin and see it wiggle instead. Because if I put a probe there, on this chip here, I should, on this pin, be seeing it scanning. Well, I've managed to go and do the same, turn the wrong knob, like the nutter I am. Okay. This one. Yeah, I'm just not seeing enough voltage swing to really do anything with triggers and so on and so forth. Wise. If I'm testing all the way down that end of the board, I can put a ground over here. That'll help my signal integrity hugely. I'm gonna double the speed of this interrupt just to see if that makes it any more obvious. Oh, I can see... I saw a blip there as the board rebooted. Welcome, my Aegis. I am having a bit of a time of it right now, as the board ain't working the way it's supposed to. If I look at this pin, it's doing the exact same thing. It's just not driving the pin high properly. Why would it not be driving those pins high properly? Don't mind me just drilling into a via with my scope probe pin. That's not getting me signal. Yeah, see, if I go looking at that pin, I get nothing. If I look at that pin, signal changes slightly, but not usefully. Let's see, this pin is low. That's also not really doing very much. That one's doing more, but it's not... Again, it's not driving high like it should. Yeah, Obliterous is having a bad time. Don't mind him too much. Right now, I'm not having a good time either, because this shouldn't be doing what it's doing. It's not something silly like the fucking pins are backwards or something on the chip. I need the processor-specific data sheet for a little pinout. Pinout and pin functions. EA0 should be on pin 26. Yeah. Port A0, pin 26, etc. Oh, and this is where the interrupt types are defined. Okay. So, which port pin was it that was giving us problems in PS2 land? It was port E pin 2? Yeah, pin 1. Port E pin 1 is synchronous interrupts. Okay, so that means that there are synchronization flip-flops in the way. That's good to know. Any tidbits of information on port A that this might tell us that the other won't? Shouldn't exceed 100 milliamps, which we shouldn't be doing anyway. If we were having overcurrent problems, by the way, we would be seeing the power to the processor resetting, which we aren't. We are not seeing that happen, so we know that that's not what's happening. It's annoying that you can't tell it to only match that case. We don't care about the event multiplexers. And we should be being sensitive to both edges, because we are resetting ASC here to 0 when we only write that we want totem pole. I wonder... let's try making a pin pull up. So instead of instead of pin 1 here being totem, let's do port OPC pull up. Which now should put a resistor on the port. And that hasn't changed the darn thing. That's... Welcome to the frustration stream, I guess. Well, we poke registers and have nothing change like it should. I am going to get my virtual machine up and we're going to go and attach the virtual machine. 1 second, please. Put my virtual machine... Oh. Restoring on the wrong screen. There we go. So, let's pull the latest firmware over. Ah, it's not the one I wanted to do. I wanted to replace the file. I hate Windows. Windows, you're terrible. Now, if I tell this to use my JTAG ICE3, and we start debugging, we are poking registers in this darn thing because it ain't working. I should have done a rebuild before I did that. And Windows, yes. Which, reasonably enough, needs poking very, very hard. Because it's terrible. Let's do a ninja disassembless. I need the sources for... I need the sources for Keyinit. Which is at hex 6D4. Let's get rid of all of these existing breakpoints because they're all garbage. Thank you. So, if we look at the port A IOs, as this bit of code runs, well, at least then I'd be able to write GA and it would mean something to the computer, right? So this is the call to writing our debug UART. We then start storing stuff into these. Or at least in theory, we just did some stores. Oh, we're storing zeros there. Okay. That was probably me making sure that this is all set right. Yeah, which it is. So register 24, then store into Z plus 6, that's out clear. So that definitely has the output pins cleared. And indeed we can see the input pin side of things says they're all low. And we just set the directions, which they are outputs now. We reset a whole pile more pins. That will be port F being messed with. And if I hold a key down in the next cycle, there we go, in is 2, and then should go back low, which, interesting, it doesn't. So these input pins are sticky when they shouldn't be. That's annoying. Why is that sticky? I have a funny feeling that the resistors... where is it on this board? Here, this resistor, for example, which... this side is ground. This side is 3.3 volts. Which is the row side of the keys. Yeah, now that I've grounded that pin through my scope probe, the pin's gone back to being ins low. So I need to put the 2K, the 20K resistors on that we missed off on purpose. Because I didn't know if we needed them, and I didn't think we did, but it looks like we do need them. So I'm going to switch to a soldering stream, and we're going to put the, it's 1, 2, 3, 4, 5, 6, 12 20Ks on that we need. Okie dokie, sleep well. You're not going to sleep because I'm going to do soldering? Okay. I'm just going to get my scope off the desk so I've got space enough for equipment. And then we'll switch. Where are my 20K? That's 1K, 4K, 10K. Those are MLCCs. There they are. You're probably going, why 20K? I've got two 20s in parallel with each other, which gets us to 10K, which is the ideal resistance for a pull down in this instance, I believe. Well, we can play with it actually. We can actually play with what the ideal is and tune it a bit, which is quite cool. Okay. Just gonna unpower the board and disconnect the programming interface when I don't throw my headphones across the table. So, let's adjust some angles. I'm going to want that about there, given soldering iron. I'll just disconnect my Glasgow for the time being, which gives you a pretty perfect view actually of some of the resistors I've got to put on. So, I can get my iron back out. Well, that was a nice bit that the debugger allowed us to see that these resistors are in fact required. That's cool. I wasn't expecting that. One, two, three, 4, 5, 6. That's a nice little pile of resistors. Come on. Oh, no. Come on. 20k bastards, come on. Oh, don't go down there. Well, that's, I'm gonna have to turn the board over to get that out. Oh, jeez. That's better. That's awful. Come on. There we go. Oof. That's pretty hardcore damaged. The next one is here, because apparently I put it in a bit. X-Gen, you're not supposed to go to bed with your laptop. That's supposed to be other pretty women, right? Yeah, that works. And for those that know me, I just made a very, very gay statement. Don't tell the wife. Oh, Nyano appears to approve. That's good. Yeah, that's awful. It's an awful joint. Far too much solder. There we go. Oh, okay, fair enough. There's the next one. That one's going to be fun to get to. I feel like... Oh, I've missed one down there, that's why. I missed this one right here. Which is also going to be a little bit fun to get to, but that's okay. So what we're doing here is we're taking the response of the keyboard when a key is released from a purely well, from the basically what we were seeing is that the transistors inside the micro weren't able to discharge the input buffers, I mean. Which is why it kept reading the input pins as high when keys were released. We're installing effectively bleed resistors for those transistors, but they're distributed across the board. Yes. Yes, it was Raichu Knight. Well, contrast on that's a bit fun. Right, let's see if I can get that resistor out. Nope, it's still in there. Let me use my other tweezers and see if I can get it out that way. Hey, there we go. I'll check it to make sure it's still a resistor and I didn't crack it, but... it seems to have not damaged the plastics too badly. It's a little tiny bit stretched, but... Let me grab the multimeter, put it in ohms mode. We want to read 20K5 on these. Ah. Well. Yes, 20K5. Nice. I managed to fish it out, Obliterous. See? Okay, there's... those resistors on that end. We now have another 6 to put on this end, starting with the one over here. There's another one there, 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 and there. Oh, it's a good question as to why Twitch lags. I have it in low latency mode, which is the funniest part. I'm streaming in low latency for you, so it shouldn't be high latency. Gotta love that. Could be to do with ping. Knowing where he lives, though, that's actually quite unlikely for him. Good answer. Which is actually quite funny, because, to me at least, because the onomatopoeia for a doorbell in Japanese is pim pom. Wow, that is awful. Awesome in the traditional sense isn't. No. Awesome in the biblical sense is actually really bad, and is more like you are filled with dread and awe on something or another. It's only a modern meaning of awesome that is positive. That is a long friggin' time. Twitch must be having some fairly major technical difficulties in that instance. Is Seattle on fire again? Yeah, that went flying. It's still on the board somewhere. The question is, where is somewhere? I can't just run my hand across it because it's too damn sharp. Oh, it's been known in the past that Seattle has had some incredibly bad days where it has literally been on fire. Ah, it pinged onto my desk. That's where it went. Let's try this operation again. Eek. I don't know them. Are they a German thing? FFF. Fridays for Future. Things being on fire is definitely not a German thing alone. Okay. On fire I was literally meaning as in the data center is literally on fire. Or having a very, very bad day as if it were on fire. OVH had a very, very recent whoopsie with fire, and an entire data center is currently no more. Actually, multiple, because it was Strasbourg 2 is gone. Strasbourg 1 is partialed, and Strasbourg 3 is partialed. 4 is nominally probably okay. Apparently I have extra resistors? Oh, whatever, I've got extra resistors. Sorry. Come in, come in. I might have been watching a lot of anime today, which is why the large quantity of Japanese leaking in. I like it, Hexgen. I like it. I would have to say I'm experiencing about 20 kilo ohm of resistance right now. And it's not bad. Aww. I'm sorry to have reminded you of that. Some of my favorite phrases at the moment include things like wagata, which means understood. Another one which is similar is kashikuremashite, which is a slightly more formal version of it, if I've understood right. Yeah, I've accidentally got an extra 2. You can't get... There we go. 2 resistors. Hey, that happens. Yeah, it does that. Your brain only recalls what it needs to. But that's all of those resistors on, so let me put some equipment away. And we'll plug this back in, and we'll see if key scanning is now a little better behaved. It should be. That's because they basically were small googly eyes on my fingers. just plug that back in. There we go, and then I can plug that back in. That way up. Just love it when my boxes come unplugged from each other. Okay. So. Oh, actually, I need the board the other way up. Done all of that, and then I just realized it's the wrong way up. Okay, so you'll be able to see when the board's powered with this. That's why I'm doing that. So if I plug my Glasgow back in, it's gonna rebuild the stream, the bit stream for it, while I put my soldering iron away. So it's now powered. And if I now oh right, because that's currently captured by the virtual machine. Haha. There we go. So if I now, there we go. That's better. That's not sorted the rest of the problem out, but that's better. Also, I should halve the scan speeds again. So, okay. This loop doesn't behave properly. But, at least now, port F in does. Which is very nice. I can get rid of some of this stuff, and this. Yeah, so that's me pressing all those keys all, whoa, at the same time. 1 second. Camera doesn't like it when you do that. Pardon the fall. Yeah. Having to sort the tripod back out now. Yeah, I'm happy that those resistors have fixed the input side of things not working properly. Stabberific. Oh jeez. So, if we... wrong one, that one. Oh, phone won't stop him. Okay. Remind me to never piss you off. Oh. Meant to do run to cursor, there we go. So as we go through this, we should go and see... That should have put stuff out on the UART. And indeed it has. So that should have made port A output. It has. I feel like I'm going to have to get my scope back on my desk in a moment. Problem is I really can't get at the pin I really need to get to for this to work properly. Or can I? I can just barely see. You can't see it because it's the wrong angle, but I can just barely see down through here the pins of the microcontroller on this side of port A is right down in this corner. I can probably get a scope probe on one of those pins. I think I want to do that. One moment. Need more PowerPoints. You do realize I am a girl, right? But fair enough. Fair enough. How do I want to do this? Because I kind of need to get the clamp for this in here. So I can then take probe and try and... That's gonna have to come off. There we go. You don't get to act surprised, Obliterous. You already knew that. Right, I should be on pin 2 of the port. I just disconnected it in the middle of debug. I am an absolute moron. What on earth? Let's do this the other way then. Not that much at the moment. I'm having a bad time trying to... get some info from this chip. There we go. I'm now attached on... More probably that was the debug register. That there's a debug register you can write, and it was probably reading that out slowly and dumping it on that console. If I was doing something useful with it, it would actually mean something, but I'm not, so... Yeah, I should be scanning right now, and this should mean that this port pin I'm on should be flipping high and bloody low, but it's not. I am on this pin right here. Decol 4. So if I temporarily take this out the mix again, and we do port A, out toggle is hex 1, 2, 4, 8. We want 8 here. Eh. And I am seeing nothing happen on the port. No key presses are doing anything, which is fine. No night Hexgen. I can't even get my finger down in there. The steel plate is really in the way right now. Yeah, microsleep is indeed bad. Yeah, I just am not seeing anything like I should on that pin. It should be toggling up and down right now, and it is not toggling. Oh, night Hexgen. 99.1. Wow. Welcome, Lofty. I am having, fun times. We've fixed part of key scanning, but the other part is still broken. So to explain to those who have just joined, what on earth is going wrong? Well, first, let me flip this over so that you can see. And I'll also get the schematics up. So, this right here is a 3-to-8 decoder with enables. And in fact is this 3-to-8 decoder right here. Now I was just trying to probe this pin here. Previously we've been looking at decol 1 and 2. And the behavior is that even though I'm output toggling the pin like crazy, if I hook up, things need to lay flatter. Sorry, cable management is being a little bit mean to me right now. Plug in these. There we go. They didn't yet. Hello. What exploits are these this time? I haven't looked in Discord yet, by the way, so... There we go, that's better. If I pop that back up so I can make my probe to it, and we look at this pin right here, which is the decal 1 here. Yeah. That one's very strictly invite only though. Yeah, that would actually be a good way of putting it. So, right now, it should be toggling the crap out of the pin I'm probing. And I can tell you, unfortunately I can't show you because my bloody scope software broke, but I can see it is very flatline. It's hovering above 0 volts, but only by like 0.3 of a volt. And if I look at the pin next door, same thing. Which is very frustrating right now. If I were to use, say, my scissors here to bridge these end 2 pins together, which is power and a data pin, and I look at the logic levels on the pins here, this end one is on when it shouldn't be, which is quite intriguing to me. Might actually mean that my connection wasn't very good. Yeah, so if I get a good connection, this pin here goes low, and the next one along goes high, like it should, but the microcontroller isn't able to drive this, which, I don't know, I don't get it. It doesn't make sense right now. So my current conundrum is why scanning, more specifically driving the I/O lines that drive these chips, isn't working. It should work, but it doesn't. So we can see I just shorted this 3.3 volts to decal 1 here. Okay. Anyway, decal here goes all the way back down the keyboard to these pins of the microcontroller, and I have checked, these are all soldered perfectly fine, these connections are happy. If we did continuity checking, or if I could do continuity checking from here all the way down the other end of the board, we should find that it's got continuity. The microcontroller's been weird. If I hold a probe against that pin as it does reset, I do see the pin drive high for a split second, and then it capacitively drains. I see a nice RC curve from the pin, which is exactly what you don't want when you're supposedly driving the pin. So that brings you up to speed with my current conundrums. The direction of port A. Pap, pap. So this is... These pins here, if we look in the schematic, are very definitely pins A0, 1, 2, 3, and 4. Oh, you definitely are. So those are on port A. Pins 0, 1, 2, 3, and 4. That's these ones here. Are being set via this column mask generation, which is, we checked already, it's 1F that is coming out, which is correct, and this one here is 3F. DIR should, when written, configure the pins as outputs. The only thing I can think that could be causing port A here to behave the way it is if it is somehow getting driven into an analog mode. Which makes no sense to me. Because we are only messing with port A in this one file. And this one file very, very specifically sets those pins as totem pole. So if we work our way down through the registers, we've got DIR here, which is me personally setting the directions as outputs. Then we've got the direction set, toggle, and clear, which I'm not messing with for that port. We then have out, which should be the data that gets driven onto the pins, with a 1 in the register being a high on the pins. Toggle here is how I'm able to just toggle a pin, which is why it's so weird that I can't see it toggling. In should reflect whatever is going on the pin. So actually, if I don't get much control about drive strength on this. I can drive up to 100 milliamps on a port, but my regulator is also 100 milliamps max, and it will cut out at that. So I have a drive strength of up to 10 milliamps, I think it is, that I can drive down the board. And we are not driving that much. There are 3 drops. I've already checked for shorts. There are no shorts between the pins up here. So the inputs are all on this top side and this pin here, with the last pin on this top edge being the last of the outputs. The bottom edge down here is all outputs, then there's ground and power. These lines here are the inputs, and I've already gone through these with a multimeter checking for shorts. There were none. Unfortunately. So in theory, this should be able to print out the state of the port, and I'm actually going to set it so that every 999 iterations through this we do that, which will mean that we should see it toggle on and off and on and off, which I bet we won't. That was a bit weird. I'm gonna need to turn the board back over though to be able to connect the debug UART. Haha. There we go. I have a cable hidden under my keyboard, my other keyboard here. So we can see the port A state is always 0, which is wrong. It shouldn't be always 0. And it doesn't really matter in what way we do this, it's not changing, which is bad. Even though we are quite clearly toggling the output pin. Which kind of confirms exactly what we were seeing in hardware. Even if I change that to say that, we're still seeing the same thing. I can actually remove the rate limiting if I move that code up. And I can do the rate limiting a different way. It does. Yes, the in register is connected to the input buffer for the port, and the output registers are connected to the output driver for the port. This is the hardware schematic involved. The simplified part that we're interested in, because I told it to be in totem pole mode, is this. So the pin itself is being driven, but the input buffer here, this is that input register. Oh, sorry. 1 second. There you go. So you got the port is being driven, but then this is buffered to the input register. So this in N is a bit inside the input register. So whatever we do on the output side of things with the toggles, we should see mirrored on the in register. Which is a nice way to be able to check what the hardware says versus what the software thinks is doing. Is that too big? No, that's okay. So yeah, that's still not toggling. And even if I slow that way the hell down, and we do only some number of iterations, let's say this is... Oh, I see what you're saying. Yeah, we could do that. Every second time I try. Yeah. So we can see internally the port should be toggling. Externally it is not toggling. It does. Disconcertingly though, if I toggle that, it ain't changing anything. It's almost pointing to there being a dead short somewhere on an output, on the whole of port A output, which is weird because no other port has that problem. And I can drive the signals high manually. Like, if I take my scissors and I short those pins again, let's see if I can do this without hurting anything. If I manually short these two pins together, there we go. So that's me manually shorting pins together. That's a very interesting thing that's happening there. Come on. Oh, there we go. Ow. That is interesting. That is very interesting behavior. There is a short. But there's only a short when the microcontroller drives the whole port high. Okay, take care, Obliterus. Thanks for watching. And joining in my misery. Let's do a thing here. Raven is on to something. They are brilliant as always. Lofty's good. Oops. So now, if I do the same short two pins together, if I can manage to maintain it. There we go. That's getting way too long a line. Let me fix that way. Whoops. That's interesting. If I hold a couple of keys in... God, I really need to fix some of the UART code, don't I? Yes. Very happily, actually. My easiest way to turn the board off is with Glasgow. Set the port voltage to 0. So if I hold that shorted, Excellent. Also, I wouldn't say it's accidental help. Now we can actually analyze what we're seeing. So that one's correct. That one is showing short. Interestingly, it's only the pins that are supposed to be high plus the one I'm shorting. Have I managed to get the pin out of these things upside down? Or some bull like that? Because this is some very intriguing behavior here as well, with the high pins aren't being driven the same. They're not part of the same short state. I'm very perplexed by this. It's more better than that, actually, Lofty. You're good. Also, you should have seen how bad debugging the USB side of things was. This chip has been nothing but throwing shit at the wall and seeing what the hell sticks. What I think I'm gonna do is I'm gonna reflow and rework. Oh! Thanks for the flow, JKIV, and welcome to the stream. I'm going to reflow all of the oops, doing that again. All of the these decoders, and I'm just gonna see if there is actually a short on one of them that is the reason why this is happening in the first place and driving me kind of, honestly, batty. So, one moment while I put my scope away again, and I do things like disconnect Glasgow so that I don't accidentally burn or short stuff that I don't want to burn or short. I'll get my iron back out. Lucky everyone that I get to do a double solder stream at this point. As it is. I don't think it would like me putting soldering iron current through it though. That one might be a bit much for it. Or indeed me putting a soldering iron through the USB cable. That might also cause some problems. Though, more for the host than Glasgow, to be fair. That's the iron back out. I am not qualified to answer that question. I would turn to you, but you're the one asking the question. Oh, that's fair. I get ya. That's the other way. This one. If it fits or something, I don't know. That feels a little bit mean, but this is where I get to struggle with really shallow depth of field. Those are some gorgeous looking joints. There shouldn't be any shorts in there. Likewise for those. I wish I could zoom in further, but I really can't. Not without getting out of macro lens at least, which I'm not really fancying doing right now. Those look like they're good joints, but we'll reflow those ones as well anyway. Because I don't trust it. Needs more flux. Yep, needs more flux. Yes. Absolutely. I hate that I'm using a keyboard to support a keyboard. So if I accidentally press too hard on that end of the board, everything's gonna suddenly start typing and just, oh well. Will be, yes. I wouldn't say it is yet, but, looks okay. There it is. Ah. Heh. Hey, see, those look fine. Oh no. That sounds like, bug-prone keyboard. I think that's where the mess is gonna be, if there is one. Oh, interesting, you can kind of see... I don't know if that's solder or if that's flux, but that top edge does look pretty... rough. Ah, very nice bokeh effect happening there. Oh, very artsy. Let's fix this awfulness. I'm thinking I might actually break out the tacky flux at the moment, which is a first for me. I've never used tacky flux before, I've never had a need. But this could be the start of that need. That's looking better. I'll quickly do an inspection of those before we do the other side of the chip. Oh yeah, that's looking decent. It's very hard to know if right in here, that's a solder bridge or not. It's unclear. Let us do this side of the chip. Okay. And actually, from this angle, we can see that there aren't any shorts in there, which is rather good. There we go. Apparently that is the max focal. Yep, that's not got any shorts. Unless in there is a short to the lead frame, which I bloody hope not. But yeah, that looks okay. That looks out reasonable. So let us try again. There we go. I'll fix the focus in a second. Just gonna plug things back in first before I do. There we go. So let's put the expansion board back on Glasgow, which is working beautifully, by the way, Eston. You'll be happy to know that the keyboard board that adapts PS2 to keyboard works flawlessly. Put my iron away. And plug that one back in. And that one back in. That is debug, monitoring, and let's go. Let's do the whole run a PS2 host. Ah, it's still unhappy. But, you know, I can press keys and it's clearly seeing me doing so. Obviously this end won't work right now. What this points to, honestly, is that the short is under the processor. Which is right here under the steel plate, and the only way to take the steel plate off is to take all the keys off. And I don't really want to do that. For obvious reasons. There are 106 keys. I don't feel like trying to do another 212 joint desoldering marathon, followed by getting them all out the key plate, followed by a 212 joint redo. That's frustrating. We've got a reasonable amount of progress here. We've got key scanning kind of sort of working. We've got PS2... I wouldn't say we've got PS2 working any further, actually. PS2 is still a bit of an enigma right now. But we have got row scanning working, which is nice. So there is progress, just not very much progress. Sorry, it's been a bit of a frustrating stream. I'm sure as much for you as it is for me. But I think this is where I want to wrap up and stop, because I'm gonna have to spend some quality time, shall we say, figuring out PS2 and key scanning. So this is still wonk. Although I wonder if the kind of wonk has changed. If the problem is with the CPU soldering, then what I'm about to do shouldn't make a darn difference. Yeah, okay. So it's definitely with CPU soldering. The first 3 pins are shorted together, kind of. They're weakly shorted together. And if I then also do a similar thing... there... we can see that all of the high pins are shorted together. Maintaining that is hard. Anyway, you kind of get the idea. Yeah, all the high pins there are shorted together. And all the low pins are shorted together. And that looks to be a CPU side problem. Because we've just reflowed the other 3. Thank you very much, Amy. The only other thing I can think to do with regards to this is I've got the back pad here. I could reflow the CPU. The problem is I can't get flux on it. And I kind of need to flux it. Otherwise it's not going to fix whatever the problem is. I can get flux on a couple of the pins. I mean... yeah, I'm going to have to get the multimeter out. I'm going to have to figure out what on earth is happening. I'm going to need to clean the backside of the board. I need to clean a lot of joints here. So with that, I mean, I haven't got much else to offer for tonight. Depending on how things go, I'll either do another SPI Flash Programmer stream next Saturday, noting that on a much happier note with SPI Flash Programmer, after reflowing the SPI Flash chip, I was able to resolve the short it was having, which means that we're actually now able to talk to both of its SPI Flash chips, which is really awesome. So in theory, that project I can actually now finish writing all the software for, and we can get to a point where it can be wrapped up. This project is going to take some further time. Yeah, I'm sorry. So yeah, we'll see. It's either going to be I do an SPI Flash Programmer stream next Saturday, or I end up managing to sort out this short and the problems that it's causing, in which case it will be an MXKeyboard stream, because I really want to get this project to a point where I'm able to use this as my actual daily keyboard. That would be, like, success, is I'm able to use it as my keyboard. So with that, I will bid you all a very good rest of your day, and I will talk to you and see you all on stream next Saturday. Thank you all for watching.